Alright, welcome back. This is Mr. D with Please Physics Tutorial. Let's look at number 18. A jet moving at 500 kilometers an hour due east is in a region where the wind is moving at 120.0 kilometers per hour in the direction 30 degrees north of east. What is the speed of the aircraft relative to the ground? So let's use GFFS for this. So, the givens. So the given section, it says a jet is moving at 500 kilometers an hour east. Alright, where the wind is moving 120 kilometers per hour in the direction north of east. So the wind is 120 kilometers per hour. Okay, and let's write it right here at 30 degrees. And you could put northeast there, but we always go north of east anyway. Alright, so what does this represent? Kilometers per hour. Okay, it's going to represent velocity. Okay, so this is the velocity, and let's call this velocity of the aircraft, so we'll say jet, so V jet, and the jet is moving at this velocity, and the wind, we'll say V wind, is moving at that velocity. So they want to know what is the speed of the aircraft relative to the ground. So relative to the ground, how fast is the aircraft going? So we want to know what the find is, so we're looking for the speed of the aircraft, so we want the speed going of the aircraft with the wind involved. So we're going to say the resulting. So the resulting velocity, so we'll say the resultant. So we want to know what the velocity of this resultant is. Alright, so how can you do this one? Alright, we have two vectors here. So let's just quickly sketch it. Alright, so here we have a jet going due east at 500 kilometers per hour. Then we're going to add the wind component in it. And it says the wind is in the direction north of east, and it's 30 degrees. So here is 30 degrees. We added head to tail, and the magnitude of that was 120 kilometers per hour. So, when you look at this, you can find the hypotenuse. So let me use a different color. You want to find this, the hypotenuse. But you cannot use Pythagorean theorem right now. So eventually the formula you want to use is Pythagorean theorem. So you want to use a squared plus b squared equals c squared. But that's not a right triangle. But what we could do is make it into a right triangle by adding the two vectors. The first vector, we'll call this one the first one. That's number 1. This is number 2. The first one only has an x component, a horizontal component. So we don't have to worry about that one. Alright, what we could do is look at the next one. And we're going to switch this from a vector at an angle, and we're going to find the parts, the components of it. So, let's draw a dotted line here. That will be the x component. This will be the y component of it. So, when we did this before, we always had to see which do we use, sine or cosine. The angle is coming off of the x-axis. So, this is adjacent, so we're going to use cosine. So if I want to find what this is, this component, I'm going to go cosine 30 degrees times the hypotenuse, which is 120 kilometers per hour. Okay, that will give me the x component. The y component, that is opposite of that, so we're going to use sine. So I'm going to take the 120 kilometers per hour and I'm going to multiply it by sine 30 degrees. Alright, right now, get that answer for me for both of them. Put it in your calculator. Alright, so when you multiplied the 120 times cosine 30 degrees, you came up with 103.92. Okay? So let's call that x2. Because this is the second vector. We'll call this one x1 for the first one. We'll call this y2 because it came off of the second vector. So x2 is 103.92 kilometers per hour. y2 is 60 kilometers per hour. Now you have your right triangle. It starts here, then it goes up. So when you find your a squared, you want to make sure you have both x's. So let's call this the resultant in the x direction is going to be x1 plus x2. So plug in those numbers. 500 kilometers per hour plus what you just found out, 103.92 kilometers per hour. Add that up, it comes out to be 603.92 kilometers per hour. So that is the total in the x direction of your right triangle. Now, you only have one y, but we're going to call it still ry. And that's going to be 60 kilometers per hour. Now, I'm going to use these instead of a or b. So I'm going to just say rx squared plus ry squared is going to give me the resulting velocity. So I'm going to say r for resultant. Now that's squared. So I need to get rid of the square, so I have to do the square root of both sides. So that's the formula you're going to plug into right now. So plug it in and see what your answer is. Alright, so hopefully you plugged it in correctly. So I'm running out of room, so I went over here with this formula. So the Rx is the Rx right here, which we figured out, 603.92. Square it. Remember the units are there too. Alright, and then the Ry squared is this Ry. So that's 60 kilometers per hour squared. Do the math, don't forget the square root, and your answer should come out to be 606.9 kilometers per hour. Now, to make this even more accurate, you would find the angle. So, you would use the formula for angle, which you derive from tangent. But, as you see, I'm limited on space, so I'm going to squeeze it in up here. So the angle is the inverse tangent of the opposite over the adjacent, TOA. So let's plug in the opposite is the y. That's opposite here because it's going this way, so we're finding this angle of that blue line, which is the resultant. So it's going to be 60 kilometers per hour divided by the adjacent, which is the total x direction, which is going to be 606.92 kilometers per hour. So right now, find that on your calculator. Right. So you should have come up with 30.5 degrees, and you can round that to sig figs of 2 sig figs. Or what might have been more appropriate is if we looked at this individually without going back. Alright, that sig fig should have been 1, so if we round that to 1 sig fig, it's just going to be 31. I'm sorry, 30. Okay. Now, your answer for this hypotenuse is 606.9. Let's check sig figs on that one. So how many sig figs here? Alright, 1, 2, 3, 4. All these zeros are important because of that decimal. So they're all significant. Same thing here. 1, 2, 3, 4. Is our answer in 4 sig figs? Yes, it is. So, it will travel at 606.9 kilometers per hour at 30 degrees, and that is your final answer. So, hopefully this is starting to click. Alright, let's continue.